All right, so I think it's recording and just the video. Homework number 6. Get homework number 6 out. Look at that. So real quick, it took a while, and I thought it was important though for us to go through it, but it took some time to go through the quiz itself. So that pretty much took up all of our time over here with the quiz, but the foldable, we're going to do that today. It's not due until March the 9th, so we still have some time for that. And I don't know if you noticed it, I tried to put everything here, pretty much most of it's gonna be in classes, we see each other 2 days a week. But for some crazy reason, if we get pushed back, at home again, then I'll have to start putting all those homeworks back to online for Blackboard. But other than that, I'm hoping that we can continue to come back as long as no other crazy disasters occur, I guess, right? So we're gonna go over homework number 6 answers, and then homework number 7 is due next time we come to class, which is gonna be March already. And it's crazy because we were just out all last week, but we have school this week, we have school 2 more weeks, and then we're out for spring break. Okay, so then we'll be out again. So our homework number 7 is gonna be due over here when we come back on Tuesday. We're going to go ahead and do that foldable and go over that today, get that prepared and set up. And then station lab, which is our lab for unit 7. You have the paper in front of you. I'm gonna go ahead and put it on Blackboard, but I didn't put it on Blackboard last night because I didn't want anybody to stress thinking they have to print it out. So I was printing out everyone the lab paper. I will put it on Blackboard just in case if something happens and you lose it or lose a page or 2, you can go print that page or 2 out. But I didn't want anyone to stress out thinking, oh snap, I've got to print it out last night and hurry up. I didn't want you to do that. So there's the lab. I don't see us getting to both parts of the lab, okay? What I see us doing is, and this is my goal for today, showing you what parts are gonna be. Remember, some of it's going to be at home, online, and that you've got to do at home. And that's what I wanna show you. Then, other than that, the other part is in school. I don't see us being able to do that. And they were just kind of craziness this week here in the science building, not about what happened earlier on Monday, but other stuff was going on with the science building. I couldn't set up our lab, our stations. So I plan to come in next week on Monday evening, so that way I can come around at nighttime, have our station set up, so Tuesday morning, it'll be ready to go. There'll be a chemical station where you'll be there mixing your chemicals, so that way you can see the properties of what happens when they combine, and then go ahead and form those 2 ions together, like write it down. There'll be a station where we'll have over here with our Bunsen burners, so that way you can melt some substance to see whether it's ionic or covalent. We're gonna have an electrode station, so there's a few stations for us to do. Again, please, and you know what, we haven't really had in-person lab kind of thing, but let me let you know that I always tell students, have your notes with you. I think that's helpful. Okay, so please have your notes with you when we meet again, because our station lab, we're gonna do the online, we're gonna go over it today, so that way you can do the online portion this weekend. I don't care if you do it Friday, I don't care if you do it Saturday, I don't care if you do it Sunday, but do it before you come. I don't care if you do it Monday, because we don't have Monday class, right? As long as you get it done before Tuesday. The only thing that you have to do on time is gonna be the part 2 quiz. Remember, this unit is actually 2 units combined into 1. The first part was like the crisscross and actually coming up with the formula. The second part is the name, which, right, we have ionic and covalent. If it's covalent, you put prefixes, and if it's ionic, you don't put a prefix. All that crazy hot mess. So the foldable, I think, is really gonna help clear that up for us, okay? So we do have the quiz. I think if we get through this foldable and you have it ready for you by the time the quiz comes around at 12 o'clock tomorrow, I think that is gonna be your biggest thing to help you out. And don't get me wrong, the notes are there, but there are a lot of pages to flip through versus the foldable. It's gonna be all in one little like booklet, and you can just flip it up and it's gonna be a lot easier, I believe. But your choice, have your notes too in front of you when you take that quiz. Just so that way we know when we come back next week on Tuesday. Next week on Tuesday, we're gonna work on that station lab, okay, together or rotate. Actually, there's gonna be the different stations, and you'll see it, you have it in front of you. I think it's 8 different stations. Also, when we meet again next week on Tuesday, go over homework number 7, okay? And then we are gonna go over the answers, okay? So like we did this week on Tuesday, I printed out the quiz, and I know there was a lot of pages, but that was because I left a lot of space, especially with the drawings and stuff. I'm gonna print out the quiz for you again, so that way you don't have to worry about it. You can have that quiz in front of you, quiz 1, quiz 2, so that way you can look at and study before you actually take the test. Just as a quick reminder, our test is got moved down or pushed back to the 9th of next month, okay? So it's still a few weeks away on the 9th. Hopefully that's helped out by pushing it back, and then after that you got spring break. Not too bad. So let's move that out the way, and let me grab homework number 6. And I got homework number 7 as well. Homework 7 is a front and back. I think there was something that we needed to scratch out on this one, okay? So we'll definitely do that before you leave today. We'll do it right after homework number 6. Homework number 6 looks like this. And for me personally, knowing if it's ionic or covalent helps me to identify, am I gonna have prefixes or no prefixes? Now, both of them, ionic and covalent, is gonna have a suffix, okay, that IDE, ide, unless it's an acid, then it's a little different than, right? So hopefully this kind of helps out. Identify if it's ionic, covalent, then go ahead and either write the name or write the formula. Don't forget, if it's ionic, we need to reduce. If it's covalent, there is no reducing that occurs, right? There was no backside to it, so only one side like that. So get your homework number 6 out, because I didn't do homework number 4 or 5, because that was just a hot mess coming back after the winter break. But homework number 6, your dot is gonna be constituted as 100% done at your 100, so. Other than that, I guess we are. Or somebody grab them. So let's go ahead and make sure, let's see what you got, let's see what I got. You never know, I can make mistakes, right? So let me zoom in a little bit more. Even though I'm videoing the class right now, I know it's not perfect and it's not very easy to see. So homework 4 and 5, I'm gonna go home. My goal is to go home and video those homeworks, take pictures of those, post those on Blackboard, video this personally, take pictures of it, post it on Blackboard. I'm still trying to put every individual homework. I still need to do the quiz as well, quiz part 1. So that's still my goal, is to kind of have that done for you. Just in case if you missed it, you can always go back and at least look at the answer key pictures if you don't want to like watch the video. Okay? So homework number 6 is where we're at. I can get my homework number 6 out. I don't know, this is moving my young bosses today. Let's see if that works so better. For me personally, again, I think ionic or covalent helps out. One more time, just so that way we're all on the same page. Ionic is gonna be a metal and a non-metal. Covalent's a non-metal and non-metal. Ionic's gonna be a metal and a polyatomic and a polyatomic, a polyatomic and a non-metal. Oh. So, C and O, those are both going to be non-metals, covalent. C and O again, covalent. H and O, covalent, because they're both non-metals. So I'm gonna put C is non-metal plus non-metal. Next one, C, carbon and hydrogen. Carbon and hydrogen is gonna be a covalent bond. Potassium, once we get to potassium, that's an ionic bond because that's a metal. The next one over here is aluminum. It starts with aluminum. I'm gonna stop right there. I know it's ionic automatically. The next one after that has an iodine and chlorine. Both of those are gonna be nonmetals, covalent. Then I've got calcium and iodine. Calcium is a metal, so that's gonna be ionic. I'm gonna go back to my contacts after today. Gotta be this classroom. Number 9 is Pb, which is lead.
Wait,
iodide.
isn't it carbon, not calcium?
Oh, good call. I can't see through the fog inside this classroom. Oh, my glasses.
The air's been out for like 2 days.
It's bad. This is horrible. I don't know how y'all wear glasses so much. I don't wear my contacts, but, ooh, y'all are good. I need to figure out how y'all do this. Allie, teach me your tricks. Sodium and nitrate. Sodium is a metal, so it's gonna be ionic. Phosphorus, and we've got penta. So the first thing is, I do see a prefix, so automatically, when it's a, covalent compound, it does have, I'm gonna say yes to prefix. So that's an indication that that's covalent bonding. Di, and then penta, it's gotta be covalent bonding. The next one, calcium, I know it's a metal, ionic bonding. Carbon, tetra, carbon's a non-metal, but the word tetra is a prefix, so that's a covalent bond. Tetra, and then we've got deca, that's gonna be, so that's a covalent bond. Di and mono, covalent bond. Cobalt 3, so I know in parentheses that that's going to be a transition metal. So as a reminder, ionic bonds are metals plus non-metals, but not only that, it can be a polyatomic plus a non-metal. It can be a poly plus a polyatomic. It could be a polyatomic plus a metal. Okay, so there's 4 different ones over there. But cobalt's a transition metal, so ionic. Iodine on iodine 2, iodine, that's a covalent bond. That's one of our 777 rules. Selenium mono is as a prefix, covalent bond. Barium hydroxide, barium is gonna be a metal, so that's ionic. Strontium is a metal, ionic. Iron 3, so the 3 indicates that that's a transition metal, ionic. And then aluminum is gonna be a metal that's on the stair steps, and it's not a metalloid, it's an exception to the rule, so that's ionic. All right, so just kind of double check over there. Let's go through the answers back to the topic again. I'm going to put no prefix. And don't forget there was an extra special rule over here. No mono on the first element, the first name, that we did not use mono. And so when I look at number 1, there's a carbon and there's a 1 behind it, but it's invisible. So I know that it should be mono, and if you have that little, you have your notes in front of you, I know in the notes when I videoed it, I mentioned, hey, it's just kind of like, one of those things that you just have to memorize, but you probably already have them all memorized already from like math class or something. So a 1 here, a 1 here, they're both invisible, the number 1s, that's okay. I don't use mono on the first one, but I have to use mono on the second one. So carbon, mono, oxide. I'm gonna stop real quick. There's a rule in our notes. The rule in our notes says that if you've got 2 vowels right next to each other, like an O and an O, monoxide, right? You're gonna go ahead and drop that one, and then you're just gonna have 1. So we weren't doing 2 O and O's together next to each other. The next one, covalent bonding, there's a 1 behind the carbon, so carbon, no prefix. There's a 2, di. The root word, ox. The ending, ide. Next one, H2O. So even though we know H2O is water, that's what you want to call it, the actual name for H2O is di. Hydrogen, mono, oxide. And only 1 O, not 2 O's. Okay? The next one, stop me if I make a mistake. Carbon, there's 4 of them. Hydrogen, there's 10 of them. I've got tetra for 4, carbon, deca hydroxide. Okay? Let's keep going. I've got potassium, which is a K. I've got Se for selenium. On ionic bonding, there is no prefix that occurs, so I'm just gonna go ahead and write the first name, potassium. Selenium, we're gonna write the root word, selen, and then the suffix at the end, ide. I've got a metal, and I've got, right behind the metal, a polyatomic, so we're gonna go ahead and write the metal as is, aluminum. Now, when I go to the polyatomics, which is on your polyatomic charts, either on your notes or whether you use a formula chart, you're just gonna name it as is. So in this case though, it's going to be carbon 8. The next one, I've got iodine and I've got chlorine, but there's only one iodine. It's a covalent bond, no monos on the first word, so let's go ahead and just write the first word. Iodine. There's a 3 for the carbon, trichloride. The next one's a covalent bond, and again, there's only one carbon, so we don't use mono because there's a 1 there. So we're gonna say carbon, tetra, iodide. Oops, I-D-E. Next one, it's a metal, lead, Pb. So we're gonna write lead. But lead is a transition metal. I know that, it's in the middle of the periodic table. What do I have to do for transition metals? I have to have a parenthesis. Even if it's just the Roman numeral 1, I have to have a parenthesis. So, did you remember to put your parentheses? Where am I gonna get the oxidation number from, Miss Munson? If I crisscross backwards this way, then this 2 was originally from the lead. Now, lead 2, did we get that? Chloride. Okay? Transition metals have to have those parentheses. That's an indication that it's a transition metal. It tells me the oxidation number. If I don't, there's no way I'm gonna know because there's more than one oxidation number. Next one, sodium and then nitrate. So in this case, I have sodium, which is a Na. Nitrate is a NO3. Let's stop for a moment, look at the periodic table. Sodium is in group 1, so that's really a +1. I'm gonna put a +1 over here. Nitrate is using my polyatomic chart, a -1. Crisscross down, NaNO3. No parentheses around the polyatomic, we'll leave it as is. Okay? The next one, number 11, phosphorus pentabromide. Okay, so let's go ahead and write that down. Phosphorus, there is no prefix, so it has to be a single element by itself with no number behind it. It's really a number 1, but invisible. Penta means the number 5. Brome is the bromine, Br5. Okay, so double check your answers. Dinitrogen, nitrogen is my element. The word di means, or the prefix di means 2. Pentaoxide, penta means 5, ox means oxygen, should look like that. Calcium carbonate, well, let's go first to the periodic table and let's look calcium. If I look at calcium, it's in group 2, so that's a +2 charge. I have to do some kind of crisscross if there's a metal involved. Whether I gotta crisscross backwards, like I did for the lead, or whether I gotta crisscross down. But there's gonna be some crisscrossing that's occurring for ionic bonding. Carbonate is a polyatomic. Go to your polyatomic chart, it's a -2 charge. Crisscross down, and in this case, when I crisscross down, what do we have to do for ionic bonding? We have to reduce, so we reduce them down to a 1 and a 1. So in that case, it's going to be CaCO3, as is, no parentheses. That is incorrect with parentheses. Let's keep going. Carbon tetrachloride. Okay, so tetra means that there's a prefix, and I know now that that's a covalent bond. Carbon, there's no mono and there's no prefix, so it has to be number 1. Tetra, tetra means 4. Chlor is chlorine, so it should look like that, CCl4. Next one is a covalent bond. So on covalent bonds, we have phosphorus, which is a P. Tetra, which means 4. The next one, I see ox, which is oxygen. The prefix is deca. So on that one, deco is 10. Or deca, sorry. It's deca. But oxide is an O. So those two vowels, the A and the O, we're gonna drop the A and leave the O. Okay? That's how it's spelled, and that's the reason why it's spelled like that. So P4O10. Next one, dinitrogen monoxide. Dinitrogen, 2 nitrogens, monoxide, 1 oxygen. Cobalt, they gave me my parentheses for 3, that means it's a transition metal. So I'm gonna go ahead and I'm gonna say +3 charge. Why is it always a +3? Because all metals are always gonna be cations. Now, nitride, if I go to my polyatomic chart, so that way I can find my nitride, it is a -3. Crisscross down, what happens? We have to reduce, so it becomes a 1 and a 1. In this case, it looks like C, little o, N. And we leave it alone, and nitride for nitrogen. The next one, iodine. We can call it iodine, but sometimes, for an example, if it's H2, they may call it hydrogen gas rather than just hydrogen. But iodine is just iodine, so and we have to put a number 2. Did you put the number 2? It's a diatomic. Remember the 777 rule? Okay? There's no reason to memorize stuff when you can just use little hints and tricks, okay? Next one, selenium monoxide. That's the covalent bond. Selenium is Se. There is no prefix, so it must be a 1. Mono means 1, so there we go. We put no number behind it. Barium hydroxide. It is going to be a ionic bond because of our polyatomic over here. Barium is Ba, so we write that as is. Hydroxide is going to be OH. Okay, I'm going to stop real quick. I've got to do some kind of crisscrossing. So barium is on the periodic table. It's in group 2, so I'm going to put a +2. Hydroxide is a polyatomic. That is a -1. Crisscross down. This 2 must cross over, so I have to put parentheses and put a 2 there. So did we do that, and did we remember to crisscross them? The next one is, or the following, all of them are going to be ionic bonding. Strontium is a metal. That is Sr. I'm going to stop real quick, go look at the periodic table. It is in group 2, so I'm going to put a +2. Nitrate, and when I look at nitrate, that's a polyatomic. I'm just going to write down what it is. It's NO3. Now I'm going to go to my polyatomic chart, find out that nitrate is a -1 charge. Crisscross down. So Sr, no number behind it. But the 2 needs to come over here to the nitrate, so I'm going to put parentheses and the 2 behind it. Did we remember to put parentheses in the 2? Because we must crisscross. Some kind of crisscross has to happen on our ionic bonds, whether it goes down or whether it goes up. Iron 3, that indicates that this is a +3 charge. Oxide, oxygen is a nonmetal in group 16 that has a -2 charge. Crisscross down. Can I reduce? No, I cannot. So it's going to be iron, Fe2, oxygen, and then it has to have the 3 behind it. Aluminum. Aluminum is a metal, which is a +3. Chloride is a nonmetal, which is a -1. Crisscross those. They cannot reduce at all. So Al, the number 1 comes behind it. Cl3, because that crisscrossed down. We'll double check our answers. I think for most of us, what's probably going to trick us is crisscrossing back upwards. Is probably we probably forget like this. Other than that, it's probably not too bad. Homework number 7 looks like this, and I think there was a mistake of something that we were going to scratch out. then you can go to homework number 7, if you have it. If not, take a picture of it. All right, just take a picture, no problem. Homework number 7 is the same thing. We're either coming up with the formula or we're coming up with the name, over and over and over. But in this case though, we're doing acids. We're doing nothing but acids on this side, and then on this side, it's a little bit of mixture over here. So on acids, we've got a couple of things that we need to remember. One thing is, if it has an H, they all have H's in front, okay? And they all have the word acid behind them, okay? But we have some that have hydro in the first name, and some that do not have hydro. Hydro means that it's an H and one element behind it. No hydro means that it's an H and then a polyatomic behind it, okay? So that's how I know. That's what gets me through this. And for myself, just to kind of help myself out, I see that there's no hydro, so it has to be a polyatomic. No hydro, polyatomic. No hydro, polyatomic. Hydro, H plus an element, okay? No hydro, polyatomic. It's gonna be an H plus the polyatomic. Okay? If that helps you out a little bit, okay? And then it's gonna be the opposite over here. Over here, they're all gonna have hydrogen in front of them. But in this case, you can see it's hydrogen and one element. Hydrogen plus polyatomic. So in this case, we're gonna have hydro. This is gonna have hydro. Just in case if maybe that might help some of us when we're doing it on test day, or we're doing it on, exam, maybe that might be helpful. So let's go ahead and go through this one. First one, nitric acid. On nitric acid, I don't care whether it's a polyatomic or no polyatomic, the first element that's gonna be here is gonna be a hydrogen for all of them. Now I'm gonna go to my polyatomic chart, and I'm gonna find nitric, and on my nitric, that's going to be NO3. But it's a little different though, because I just can't look for nitric acid. I need to come over here, and nitric acid is IC, so it has to be nitrate acid, okay? Nitrate acid is really the word that I'm looking for on my polyatomic charts, okay? Let's go look at the next one. Chloric acid, there's a polyatomic chart. Now, first thing is, I know it's gonna have a hydrogen in front of it. I need to go to my polyatomic chart, and that's actually a ClO3. Now, how do you know it's ClO3, Ms. Munson? It has an IC, I need to go and actually find the chlorate, ATE name, and when I find the chlorate name, then that is ClO3, okay? And if you want, I can get those other notes out as well so we can have the polyatomic chart in front of us to kind of help us out. The next one, acidic acid. All right, acidic acid, let me go to my polyatomic chart because I'm not looking for acidic acid. I see that this is an IC right here, and IC is an ATE. So if you want to, ATE, acidate, come over here. And so when I look over here, it's gonna be ATE, C2H3O2. I don't care about the charge, okay? So let's come over here. It's because it's +1 and hydrogen's a -1. So C2H3O2. But again though, I need to remember that if it's a polyatomic, I know what I'm looking for. If it's an ick, I need to go look for the 8 on the polyatomic chart. If it's an us, I need to look for the 8 on the polyatomic chart, okay? Let's come over here, let's look this way, and let's work it the other way. Okay, so first one, all of them are gonna start with an H because they're acids. They're all gonna end with the word acid because they're acids, okay? First one, I have an H, and then I have a polyatomic. So I'm gonna come to my polyatomic chart, ClO. ClO, 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 okay? So ClO, there's no number behind it, so it's gonna be this one right here. Cause look, this one has a little 2, this one has a little 3, this one has a little 4. Okay, so here's my word that I'm gonna use, or that's gonna be my polyatomic. Okay, what do you do when it comes to acids that have a polyatomic? No hydro. So we're not gonna use hydro. We're just gonna use the polyatomic name, and this is it right here. So let me come over here so I can write that down. H, Y, P, O, C, H, L, O, R. It ends in an I-T-E. I-T-E. I'm gonna stop real quick. I'm gonna come over here. I-T-E changes to an O-U-S. So now O-U-S, acid. Now I named it. Okay? The next one is a polyatomic. Let's practice this again. I'm not going to use hydro. I'm going to go find PO4 on my polyatomics. PO4. Here it is right here. Phosphate, ATE. Now I'm going to come over here and I'm going to say ATE is going to change to an IC. So ATE to an IC. Now let's go ahead and write in the name of it, because that's how we name it. Phosphate, P-H-O-S-P-H, not A-T-E, phosphoric acid. Okay, we leave out the A-T-E, change it to I-C, and then we write the word acid. The next one's in hydro, okay, because why? There's one H and one element, so hydro. Now, in this case though, when I have a hydro, I'm gonna write the root word of the element and then the ending IC. So hydro, chloric acid, okay? The one that we are scratching out is gonna be right under it. So this is the one that we're scratching out. So I apologize, I need to take that one out. Other than that, it's like a practice. It's a practice over and over. It's like one of those kill and drill kind of things. Okay? There's a backside though, so don't forget it. The backside is going to be a mixture. Okay? I like this one because now you're having to think of a little bit of everything here. I don't see any acids, so it's really ionic covalent bonding without acids. The other page is nothing but acids. You're going to be sick and tired of those. So homework number 7, I'm moving that out the way. So we did homework number 6, we looked at homework number 7. Hopefully practice, drill and kill is gonna make us better at this for the homeworks. I'm gonna move my homeworks out of the way. And we've gotta get to this foldable. We're not gonna do the answers and stuff on the foldable. We're gonna put it together and I'm gonna show you how to put it together. You're gonna have to do this part, the other part on your own. So first thing, foldable.